In this session, I want to focus on the most critical dimension of a modern fleet management of embedded device, that is cybersecurity. Today, cybersecurity is no longer just an IT concern. It is a strategic business priority, especially for manufacturing companies that deploys thousands of connected devices into the field around the world for different customers. And let's begin. So, um, unlike servers or PC, embedded devices operate in an harsh, constrained, and long-lived environments. That means that device often stay in the field for 10 or 15 years. They run on custom hardware and software stacks, and many devices operate with intermittent connectivity. Also, the physical access is often uncontrolled, and updating them is risky and sometimes impossible, and can compromise the business continuity of the device. Uh, all this means that the typical IoT security model and solution simply doesn't apply for the embedded device. An exploited vulnerability in a cloud service can be patched and released in minutes, but a vulnerability in an industrial gateway deployed in a factory or in many devices in the field can take months or years to be completely removed. And attackers and hackers know this. That's why embedded fleets have become a prime target. They are often the weakest link in the digital ecosystem. The today's threats landscape affects embedded device at multiple layers. There are supply chain vulnerabilities because our products are integrated to third-party libraries, open source packages, board support packages, and firmware components that may be shipped with vulnerabilities that are unnoticed until after the deployment. There are remote exploitation because device connected with a cellular line or with the Wi-Fi or wired networks are in the attack surface and can be targeted from anywhere in the world. They are connected. There is also the risk of physical tampering. Devices in the field can be physically accessed, manipulated, and reverse engineered. So it's not secure, the physical access. There is the risk of over-the-air update interception or manipulation. If an update, for example, is not securely signed and verified, attackers can inject malicious firmware in the device. And there is also the risk of credential leakage and weak identity management. For example, related with the hard-coded password or shared credential among the fleet of the device, or missing device identities that are just some example of threats that are widespread in the embedded system also today. There is also a life cycle drift. That means the longer the device remain deployed in the field, the more the security diverge from the beginning. That because there are new vulnerability that progressively are discovered, and the device that were secure some months ago are no more secure in the field. So in short, cybersecurity is no longer an event. It's not longer something that you address one time. It is no longer an ongoing battle. It's something that you have to face in every steps of the product life cycle. Also, the regulatory landscape is changing. It's important to recognize that the cybersecurity for embedded device is not only a technical challenge, is even more a regulatory obligation right now. Governments, EU, industry bodies worldwide are introducing frameworks that impact how manufacturers must design, update, and maintain the device in the field. Here are listed some of the key regulations. For example, the NIS2 directive that is enforced from the 2024 impacts a company operating in the manufacturing, energy, transportation, healthcare, and many other essential and important sectors. For embedded device, they requires a strong asset and device inventory. That is what we cover with PMS, for example, vulnerability management integrated into the operation, secure software, update, and supply chain. The manufacturer needs to report incident within 24 hours. And they need to ensure the business, to have process to ensure the business continuity. So for companies deploying fleets on of embedded device, that means that a secure lifecycle management become mandatory, and it is not more an optional. The EU Cyber Resilience Act is perhaps the most significant regulation in the IoT embedded system. The CRA apply to any product with the digital elements. That means with hardware and firmware inside. So everything that is digital is included in the CRA, like embedded device, consumer IoT device, industrial gateway, device with AI in the field, connected machinery in the industry. Everything is must be compliant with the CRA. The key obligations includes the vulnerability handling process through the entire life cycle of the device, a secure by design principle in the development of the device, and the generation and the maintenance of a software bill of materials with a security update for many years after the release of the first product. And it is also mandatory reporting the exploited vulnerabilities. The penalties for the CRA is 2.5% of the global revenues of the manufacturer, up to 50 million. So CRA enforces the companies to adopt continuous security management. Another regulation is the VRED, that targets the device with the wireless communication, whatever it is, Wi-Fi, Bluetooth, cellular line, 4G, 5G, whatever. Manufacturer of wireless device must demonstrate the protection against network attacks, protection of the personal data, and robustness against unauthorized access. And lastly, a secure update mechanism. So secure boot and trusted boot are not just best practice like some years ago, are now they becoming compliance requirement for this regulation. Moreover, there are many other different industry-specific regulation, like ISA 62443 for the industrial cybersecurity, MDR and the ESC 8100 and the customer IoT regulation with the ATSI 303-645 that required different requirement for every regulation, but most of them are similar of what the CRA and the other regulation ask. So together, all these regulation show that the manufacturers must manage security continuously through the entire life cycle of their device. From the SBOM generation and monitoring, they need to secure the over-the-air update process. They need a vulnerability tracking mechanism, and an auditability is also mandatory to track everything that is happening on the device. This is exactly why platforms like ToloMEO are becoming essential, because they can solve and can assist you to be compliant with most of these regulation. The key security requirement of all these regulation are listed in this slide. Companies must adopt a secure lifecycle approach to cover of this requirement. The first one is secure manufacturing, ensuring that each device has an identity from the day zero. So every device is unique, and it can be identified on the cloud and on the field. They need continuous vulnerability tracking mechanism, ensuring the SBOM is automated scan to detect new vulnerabilities that may affect devices in the field. And company must also secure that updates are available to delivery patches with signing mechanism, fail-safe rollback to be protected against problems in the update, and a phased rollout to deploy the updates in the field in stages. Manufacturer companies also need a runtime monitoring mechanism to detecting anomalies and unexpected configuration or unauthorized modification of the device in the field. And finally, they need also to have a process to manage the end of life and the decommissioning of a device, ensuring that data is wiped out of the device, the key, the certificates are revoked after the end of life of the product. The ToloMEO platform address all of these requirements, as is designed to guarantee cyber security in all the life cycle of the product. We manage the identity of the device on the field with the connection with the cloud. We guarantee the secure boot and the firmware integrity. That is the system that enforces the verified boot of chain in the device. So any software installed in the device is signed and cannot be affected by malware. ToloMEO also has a strong software bill of material management, tracking the software bill of material of every firmware version and continuously check it for new vulnerabilities to ensure that the device is deployed in the field as no vulnerability. And ToloMEO also support, as we saw in the previous section, a strong OTA over-the-air software update mechanism with cryptographically signature and end-to-end validation with the rollout and rollback mechanism to secure the availability and the security of the update. ToloMEO also secure the data flow, the telemetry, logs, sensor data, and whatever that is generated from the device to the cloud, securing the connection. And it also provide audits and the log of everything is happening on the device. So ToloMEO can be a strong component of the development of your products. In the end, cybersecurity is not just a defensive requirement right now. It is a security enabler. Is something that enable your business to work properly in the field, enables the OTA update, and allow the companies to adopt, for example, artificial intelligence on the edge device without risk. Cybersecurity also build trust between the customer and the regulatory bodies. So it is something that can unlock a lot of potential in your business. So it's not only a requirement. ToloMEO O.S can be a core component and a support for you in the development of your product and in the compliance with the cybersecurity.